Imagine a creature so fast that its wings become a shimmering blur to the human eye. Hummingbirds are the ultimate precision pilots of the natural world, performing maneuvers no other bird can match. They can hover in mid-air with the rock-solid stability of a high-tech drone. To understand how they do this, we must dive into the complex world of fluid dynamics and biomechanics. Most birds generate lift only on the downstroke, but the hummingbird is fundamentally different. A hummingbird rotates its wings in a unique figure-8 pattern to stay aloft. This motion allows them to generate lift on both the forward stroke and the backward stroke. Roughly 25% of their total lift is actually produced during the upstroke. This symmetrical power distribution is what allows them to remain perfectly stationary while feeding. Their wings can beat up to 80 times per second, creating a low-frequency hum that gives them their name. At these speeds, the air behaves more like a thick syrup than a thin gas. To stay airborne, they create tiny tornadoes of air known as leading-edge vortices. These vortices sit right on top of the wing, lowering the air pressure and sucking the bird upward. This is the same aerodynamic trick used by insects like bees and dragonflies. However, hummingbirds are much heavier than insects, making their feat of strength even more impressive. Their shoulder joints are incredibly flexible, allowing the wing to invert almost completely. This structural flexibility is key to their ability to fly backward and even upside down. The skeleton of a hummingbird is a masterpiece of lightweight engineering and extreme durability. Many of their bones are hollow, yet reinforced with internal struts to handle the immense pressure of flight. Their chest muscles are massive, accounting for nearly 30% of their total body weight. These muscles act like high-performance engines, burning fuel at an incredible rate. A hummingbird's heart can beat over 1,200 times per minute during active flight. To power this intense activity, they must consume more than their body weight in nectar every single day. Their metabolism is so fast that they are constantly on the brink of starvation. When they sleep, they enter a state called torpor to save energy by dropping their body temperature. The physics of their flight is also influenced by the unique shape of their primary feathers. These feathers are stiff and sharp, cutting through the air with minimal drag and maximum efficiency. High-speed cameras reveal that their wings actually twist and deform during every single stroke. This aeroelasticity helps them adapt to changing wind conditions in a fraction of a second. Even in a heavy rainstorm, a hummingbird can maintain its position with millimeter precision. They use their tails like a rudder on a ship to stabilize their body against turbulent gusts. The brain of a hummingbird processes visual information much faster than a human brain can. This allows them to navigate through dense foliage at speeds of 30 miles per hour without crashing. Their eyes are positioned on the sides of their heads, providing a nearly 360-degree field of view. This incredible vision helps them detect predators and find flowers from great distances. The iridescent colors on their feathers are not caused by pigments but by structural physics. Microscopic structures on the feathers refract light, creating a brilliant metallic glow that changes with the angle. This phenomenon is known as thin film interference, the same effect seen in soap bubbles or oil slicks. The beak of a hummingbird is also a specialized tool designed for high-speed extraction. Some species have beaks that act like spring-loaded traps to catch tiny insects in mid-air. Their tongues are long and forked, using capillary action to pull nectar into their mouths. Every aspect of their anatomy is fine-tuned for the demands of high-energy hovering. Scientists use wind tunnels and laser sensors to map the invisible air currents they create. These studies help engineers design more efficient rotors for tiny flying robots and drones. The hummingbird represents a perfect intersection of biology and advanced physics. They are living proof that evolution can find brilliant solutions to the most difficult mechanical problems. Watching a hummingbird is like watching a masterclass in the laws of motion and energy. Despite their tiny size, they are some of the most resilient and capable flyers on the planet. Next time you see one, remember the incredible physics happening right before your eyes. The hidden world of the hummingbird is a testament to the wonders of our natural universe.